Hello, welcome to Unit 2. We're starting with solving algebraic equations, and this starts with polynomials. Okay, so first thing, don't expect you to know what polynomial is already. First question we need to answer is, what is a polynomial? Okay, so a polynomial is either a sum or a difference of algebraic terms. Okay, there's one that we've seen quite often in National 5, which is quadratics. Okay, so quadratics we already know, for example, which would be x squared minus x plus 4. So quadratic is also a trinomial, which we know for factorizing, but that's not to do with this bit. Okay, we have cubics, which are, for example, 2x cubed minus 3x squared plus x minus 10. Is an example of a cubic. And we have quartics, which are, for example, x to the 4 minus x squared plus 2. Okay, so it's a mixture of addition and subtraction of algebraic terms, and we can have a number on the end. Okay, really important thing is that all indices or all powers must be whole numbers. Okay. Right, so when we're talking about polynomials, we talk about the degree of a polynomial, and we talk about coefficients as well. Right, so the coefficient we should know already. So the coefficient of a number or of a term, of an algebraic term, is the number in front of it. Right, so for example, if I have 5x squared, the coefficient is the number in front of the x, so therefore the coefficient is 5. Okay, so the coefficient is always the number in front of the term, like the algebraic term. Okay, the degree of a polynomial is the highest power in the polynomial. Okay, is the highest power. Right, so for example, if I've got x to the 6 plus 4x to the 5 plus x to the 3 plus x plus 2. Okay, the only one that we need to look at for this is our highest power, so we find our highest one, which is 6. So we can therefore say, therefore, the degree is 6. So it's a 6th degree polynomial. Okay, right, so that's it for coefficients and degrees of polynomials. Right, so a little bit more about polynomials before we keep going though. Right, so polynomials are something that we've seen quite a lot of with quadratics. We've not really seen cubics or quartics, but they follow kind of similar rules, and they all have roots. And the way to be able to figure out the roots of a polynomial are if we set it equal to 0. Okay, so for any polynomial, Okay, if f of a, so if we put some number a into our polynomial and we get 0, that means that x take away that number is a factor of that polynomial. Okay, and we can kind of conversely say that, so the converse or the opposite is also true. Okay, and that is that if x minus a is a factor of f of x, then f of a equals 0. So if we put that a value into our polynomial, we will get an answer of 0. So what this means is if we have a polynomial, for example, f of x is equal to x cubed minus 2x squared plus x plus 7, and we could get asked, is x plus 2 a factor of f of x? Right, so this is saying we're putting, so it's x plus 2 is a factor, so it's the opposite. Remember with roots, it's the opposite, so it's f of minus 2. So we get minus 2 cubed minus 2 times minus 2 squared plus minus 2 plus 7. So we're going to get minus 2 cubed is minus 8 minus 2 times minus 4 squared, which is 4, minus 2 plus 7. So we're getting minus 8 minus another 8 minus another 2 plus 7. So we've got minus 16 minus 18 plus 7 minus 11. So therefore x plus 2 is not a factor. Okay, so if we put that number in and we get 0 out, that means it's a factor. If we get something other than 0 out, it's not a factor. Okay, so this is trying something new. We should have two different things up. One is for the link to the previous playlist for Unit 1, and the other is going to be for the second video on, so the one that we're going on to next, which is long division. And please like, comment, subscribe, leave any comments if you've got any questions. Subscribe if these videos are helping you, so I kind of have a rough idea of who's watching, and liking the video would be nice too. Thank you.